Alright, in this video we're going to look at the metric system and unit conversions. Now, hopefully this is nothing brand spanking new to you. It's something you've probably heard in every science class since middle school. Hopefully just a refresher, but don't check out of the video quite yet. At the end I'm going to show you something that's probably a little bit newer. Alright, let's talk about the metric system. So why do we use the metric system? Well, here's two questions for you. The first one is, how many inches is there in 3.2 yards? And how many feet in 4.71 miles? Can you do it? You got to divide by some things and multiply by some other things or type it into Google. But basically, it's just not that easy. Let's look at the second question then. How many centimeters is there in 3.2 meters? Well, that's easy. You just move the decimal place over 2 places, so there's 320 centimeters in 3.2 meters. How many millimeters is there in 4.71 kilometers? Well, that's easy. You just move the decimal place over 6 places, so 471,000,000. And that's meters. So you see how easy that is? I could do it in my head. The other questions, though, not so easy. And so the metric system is a lot more beautiful, a lot more useful than our kind of standard system, and that's one of the reasons why we use it in science. The other reason we use it in science is because most of the research world uses the metric system, and so then to kind of keep us on an even playing field, that way no one has to convert anything, we just all chose to use the metric system. 3 basic metric calculations that we will take in general chemistry are going to be mass, length, and volume. To get the mass of something, we're going to use scales, digital scales, actually almost identical to the one you see here in this picture. And the units for mass, the base units, are going to be grams. And you symbolize that with G. To measure length then, we would use the meter stick. And the units for length are going to be meters. And that's symbolized with M. However, in chemistry, since we're dealing with small things, a lot of times we'll use centimeters or millimeters, which are just some fraction of the meter stick. And then lastly, volume. The main way that we can measure volume is with a graduated cylinder. That's how we would measure liquids. You could do it with a ruler if you were using a solid, but we measure it in liters, which is symbolized with L. However, just like with length, we use smaller units, so we typically use the milliliter for volume. Alright, so here's how to make the basic conversions in the metric system. So there is 6 different main prefixes that go with the metric system. We always start with a base unit, and so that would be with nothing multiplied to it, no prefix. And the base units are the ones we just looked at. So if you're going for mass, the base unit would be just grams. If you're going for length, the base unit would be just meters. If you're going for volume, it would be just liters. From there, we can convert those base units into one of the prefixes. So for example, if it was kilo, and it was volume, it would be kiloliters. If it was centi and it was mass, it would be centigrams. To convert from one to the other, like I'll take that practice from the second slide, we looked at 3.2 meters, and we wanted to know what that was in centimeters. So to do that, we just find where we're starting out. So in this case, we're starting out in meters, which would be the base unit, which means we're starting right here. And the problem there asked us to find centimeters, so that right there would be the centi mark, which means we need to go to right there. So to get from here to here, we need to go 2 places down. And so then in order to convert this into centimeters, we would take our decimal, we would go 2 places, and so that means it'd be 320 centimeters. So an easier way to remember this is by just looking at the symbols. And so we would just write them up going from left to right, KHD, and then a line that represents our base unit, so just grams, meters, or liters, and then a lowercase d that kind of separates these two, deca from deci, C and M. The way you can remember this then is King Henry died drinking chocolate milk. Helps you remember the order, and that way you can convert things pretty easily. Alright, let's do a couple practice problems together. As you can see at the top of my page, I've already written out that King Henry died thing. That way I can use that as a reference as I'm answering these questions. So let's take a look at the first one together. In this case, we want to know how many grams, that's base unit right there, are in 56.3 milligrams, that's that M right there. So that means we're converting from little m to base unit. So that means we're going to take our decimal and go 1, 2, 3 places. You notice how my pen moved to the left. That means we're going to move the decimal place 3 places to the left. So we take our decimal right there, go 1, 2, 3 places, fill in those blank spots with zeros, so 0.0563 grams. So that's how many grams there would be in that many milligrams. We can do the same thing if we want to go from meters into kilometers. So this time we're starting on the base unit because we've got 31 meters and we want to turn it to kilo right there. So 1, 2, 3 places to the left, which means that we would take our decimal again right there behind the 1, 1, 2, 3 places left. So 0.031 kilometers. At this point, go ahead and pause the video. Try and do those other 3 conversions. Once you're ready, once you've got them, go ahead and resume the video. I'll show you the answers and you can check yourself off real quick. All right, so here you go. Your answers should look very, very similar to these. Make sure that you have the zeros in the right places and you move your decimal the correct direction. Also, make note that in all of my numbers, so I put units there. In chemistry, there is absolutely no naked numbers. Nude numbers are not allowed in science. It's not appropriate for a school setting. So anytime you write down a number, put down units after it. All right, so those 6 units that we just worked with, those are the main ones. Those are the ones you're probably familiar with. There is other units. It goes a lot farther, both directions, to the left and to the right. In chemistry, since we're dealing with extremely small things, we don't often deal with things like kilo. We a lot of times will deal with things much, much smaller, like nano. However, there is larger things. Giga, you probably recognize that from gigabytes on a computer. Now, to get to these units, what we've done so far is we've just dealt down there to milli and up here to kilo. We haven't gone to mega or giga or micro or nano. And to make those conversions is not quite as easy as doing the whole FWEEP thing and moving the decimal. And that's because if you look right here, we go 1, 2, 3 places to go from deci to centi to milli, and then when we go from milli to micro, it's not 3, 4, it goes to 6, which means there's actually a couple spaces in between these two. So if we wanted to go from micro to centi, for example, we wouldn't go 1, 2 places. We would have to go a lot more places than that. So for example, let's say we wanted to convert 470 micrograms, so that's a very, very small amount, into centigrams instead. So we want to get that to centigrams. So micro is right here, centi is right there. We can't just go 1, 2 places. Instead, what we want to do is we always want to do the base unit conversion. And so what that means is converting this first into the base unit, so into just grams, and then from grams, getting it into centigrams. So to do that, we can see right here that there's a -6, which means that we have to move the decimal 6 places to the left to get to our base unit right there. And so if we take our decimal right there and go 1, 2, 3, 4, 5, 6. That means we would have 0.000470 grams for our base unit. So to get then from grams to centigrams, that's easy. We're right here at our base unit going down there. So we would go 1, 2 places to the right. So we just take our decimal and go 1, 2 places to the right, which means we have 0.0470 centigrams. At this time, let's go from 0.56 gigaliters into milliliters. So gigaliters, that would be up here at giga, and we want to go down here to milli. We don't just count the number of FWEEPs to go from giga to milli. We've got to do a base unit conversion first. So we've got to go from giga into just liters. So we see right here it's a +9, which means we're going to have to move the decimal 9 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So that looks like 1, 2, 3, 4, 5, 6, 7 zeros. So 5, 6, 1, 2, 3, 4, 5, 6, 7 liters. To get that into milliliters then, so now we are at the base unit, we would go 1, 2, 3 places to the right. And so that means we're going to add 3 more zeros to get there. So 5, 6, 0. So we'd wind up then with 10 zeros behind that 5, 6, and that would be how many milliliters there is in 0.56 gigaliters. All right, that's a little bit of review, a little bit of new on the metric system. There is other units that we'll talk about, things like pico, that we'll introduce later on in the year. But for now, this is just a good introduction on how to do conversions for non-common prefixes.